example actually involving mathematical induction. So, since the commercial I wanted to show you is not working, screw technology doesn't actually want to work, really quickly we'll go back over mathematical induction on the first page. So the principle of mathematical induction requires three pieces. One, we have to show it for k equals 1, or for n equals 1. Then we need to assume it for k, and we need to show it for k plus 1. Okay, so let's do an example of how this works out in praxis. So here's our problem. We're going to use mathematical induction to prove the statement is true for all positive n's. Okay. For all. I didn't write that in. Okay. So the first piece of mathematical induction, we need to show it for k equals 1, for n equals 1. So easy enough. If we take 4 times 1 minus 1 equals 1 times 2 times 1 plus 1. 4 minus 1 is equal to 3. And then this ends up being 1 times 2 plus 1, which is 1 times 3. Dang sake. Okay, come on. Stop. So we get 3 is equal to 3. So it's true. That's step A. So we plug in 1 for n. The next step is really simple. We assume it for step B. Assume for n equals k. So that means wherever I see n, I replace it with k. So that's 3 plus 7 plus 11 plus 15 plus dot dot dot. We'll use a different color for k. We'll use orange. Plus 4. And then we'll replace it with orange. K. Back to that. Minus 1. And that will equal. We'll use the same orange to represent k times 2k 2k plus 1. Okay, easy enough. Step 3, we need to show n equals k plus 1. Right. So that means we're going to use a different color for k plus 1. So we're going to let k plus 1 be this purple right here. Okay. So if I plug in k plus 1 to the equation, we'll use purple for k plus 1. Minus 1 equals k plus 1 plus 1. If you distribute and simplify it, we get k plus 1, and then 2k plus 2. 2 plus 1 is 3, so 2k plus 3. So we have to show this is true. Okay? We have to show that this particular piece is true. So we have to get that after all of our work. So let's go to a new page. So if I break down this sequence, let's use it. This ends up being, of course, numbers to work here. So we end up with 3 plus 7 plus 11 plus 15 plus a bunch of numbers. Plus 4k. We end up with 4k plus, sorry. Plus 4k minus 1 plus 4 times k plus 1 minus 1 is going to equal there you go. We'll just leave it like that. We'll just leave it like this for now. Okay. So the idea here, we have pieces of a puzzle. We have pieces of a puzzle. The idea is we're trying to form the pieces of the puzzle here. Okay. So this piece of the puzzle is what we call S of k, or our P of k from earlier. Right? That's from the earlier piece of the puzzle on the previous page, right for that here. We found that here on this page right here. You see how we plugged in k for that. So we let that be our S of k, and we'll come back to what I mean by that, or our P of k. And so we end up plus 4k plus 4 minus 1, which is of course 4k plus 3. We'll leave that be. Alright, this statement here, P of k, becomes this right here. Right? I can use either side of the equation. This side's prettier, so we use that side because it's simpler. Okay. There's more than one way to do this proof. There's more than one way to use mathematical induction. This is just one way to do so. So this ends up being k times 2k plus 1. Everybody follow. Right? This piece here is k plus 1. That piece is k. Okay. Now, from here, we simplify this hideously ugly expression. So it becomes 2k squared plus k plus 4k plus 3. Correct? Very good. 4 plus 1 is obviously 5. Then with 2k squared plus 5k plus 3. Now from here, we need to factor the situation. This factors. Right? Factor it. 3, 1, 2, 1. Opposites, right? Because we're trying to get 5. So 2 times 1, so the 1 multiplies the 2. So we end up with 2k plus 3. And we end up with k plus 1. Alright, so it goes in the opposite spots. 2 multiplies the 1. And then 1 multiplies the 3. Okay. This statement here is exactly the same as, let's go back a page. Exactly the same as this here that we found earlier. So, since the two of these statements match, what we can state now is that therefore, we'll use the three little dots for therefore, by mathematical induction, we have 3 plus 7 plus 11 plus 15 plus dot 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 plus 4n minus 1 equals n times 2n plus 1 for all. That symbol, by the way, is an upside down A for all n greater than or equal to 1. Okay, that's how we do mathematical induction. It's a little bit long. I know it's longer than my normal 10-minute shut up clock, but these take a little bit extra time. So now that I've yapped my mouth for a little bit too much, I want you to try one on your own, which is similar to that problem. So let's have you try this. So n and n plus 1. I want you to use mathematical induction to prove it.